Now let's try to solve this problem. This is tutorial number 19 from compound stresses, the chapter compound stresses. Here we have got the problem. You can see over here. I hope you are seeing it. Here he says the state of stress at a point in the material is, the figure is shown below. Okay, he is showing us here. Now what he wants us to find out what? The direction of the principal planes. Number 2, the magnitude of the principal stresses, the magnitude of maximum shear stress and its direction. Indicate all this information on the graph. That's what he says. Usually this type of problem will be there in your final examinations. Now see, I have written over here, he wants theta 1 and theta 2. These are the direction of the planes for maximum and minimum principal stresses, that is sigma 1 and sigma 2. He wants us tau max. Okay. I have written the formulas here separately. Tan 2 theta is equal to 2 tau xy by sigma x minus sigma y. Sigma 1 is sigma x plus sigma y by 2 plus, there is a big formula in your PowerPoint presentation. I have made it short, tau max. Sigma 2 will be what? Minus tau max. See? Same thing with plus, here it is with minus. And your tau max is this value. Is this clear? When we are solving, then we will find out the theta for this also. Now with this information, let us try to see here. What is this? This is your sigma x. This is your sigma y. This is your tau xy. See this direction, be careful. This is the direction for plus. Okay. If it is in the opposite direction, it should be minus. This you keep in mind, okay? Because then sometimes the problems, it will be in the reverse direction and you forget to see that. Now let us try to find out what? Let us try to find out tan 2 theta. Okay. So I will just write over here. Tan of 2 theta is equal to 2 tau xy. 2 tau xy is how much? 2 multiplied by how much is this? 80, isn't that? 2 into 80 divided by what? Sigma x minus sigma y. Okay. Sigma x is how much? 180. Minus sigma y is 120. Okay. So how much is this value? This value is 2.67. If you 2 into 80 is 160 by 60 is 2.67. Okay. So now what will happen to 2 theta? 2 theta is equal to tan inverse of 2.67. If you do this one, tan inverse of 2.67 is coming as how much? 69.44. Therefore, theta is equal to how much? Theta is equal to 69.44 divided by 2. Okay. So this value will be how much? 34.72. Theta 1. This is 34.72. This is 3. Okay. Degrees. This is your theta 1. Okay, Shuman. Theta 2 is what? Theta 2 will be equal to theta 1 plus 90 degrees. That is 34.72 plus 90 degrees. Okay. This becomes how much? This will be 124.72 degrees. I hope you can see it because my pens are in really bad shape. This is your theta 2. Okay. You have your theta 1 and you have your theta 2. Now what can we do is, we can just draw them over here just to show. See, from vertical you have to take, always from vertical, understand? This side if you go, this is positive. How much is this? 34.72. Let us say 34.72 is somewhere over here. This is how much? This is theta 1. Okay. Theta 2 is where? Theta 2 is 90 degree to this one. Add it to this plane, another plane here. See, okay. So this is how much? This is theta 2, because you have already added 90 degrees here, right? So these are the two planes you have. So how are the forces on this one? I mean stresses, we will write it later, okay? First we finish this one. So your theta 1 is done, theta 2 is done. Now here you have what? Sigma x plus sigma y by 2 plus tau max. Let's try to find out tau max first. Okay, where shall I do? Let me do it over here. There is space over here, I can do it. Tau, I think you can see it, is it? Yes. Tau max is equal to how much? Square root of how much? Sigma x minus sigma y by 2 whole square plus tau xy square. Now just substitute the value. Sigma x is how much? 180 minus 160 divided by 2 whole square plus 80 square. This one is, if you do it, it is coming out to be how much? Root of 7300 it is coming. This turns out to be how much? 85.44 megapascal. This is your tau max. Okay, where this tau max will act? This tau max, because he is asking us in the problem, see the magnitude of the maximum shear stress and its direction it is asking. So it will be at an angle of theta 1 plus 45. Okay, so you already have theta 1 over here. Add 45 to it. How will you add 45? Let me use another color. You have this one 90. Do it exactly in between, you know. Draw a line like this. This angle is how much? 45. Theta 1 is at 45. This is the one for tau max plane. Understand? This will be for sigma 1. This one will be for sigma 2. Okay. So now what did you do now? Now you found out theta 1 done, theta 2 done, tau max done, and the direction for tau max also done. Now you need to only find out sigma 1 and sigma 2, which is quite easy because you already have tau max with you. Okay, so now what I will do, let me just delete this. If I delete it, I will have space to do my work. Did I mark the values? Okay, anyway, I will write it again here. Theta 2 is 124.72. Where shall I write? I will write here. Theta 2 is equal to 124.72 degrees. Theta 1 is equal to how much? Theta 1 is equal to make minus 124.72 minus 90. If I make it how much? It will be 34.72 degrees. Okay, theta 1 is then, theta 2 is then. If you add 45, you have for this. Okay. So now the next one is what? The next job is for me to find out sigma 1 and sigma 2. Okay. Sigma 1 is how much? Sigma 1 is equal to sigma x plus sigma y by 2 plus tau max. Sigma x is how much? Mu tamanin Zaid mu ashrin divided by 2 plus tau max is how much? 85.44. How much is this value? 180 plus 120 is 300 by 2. 300 by 2 is mu khamseen Zaid 85.44. This gives me how much? 150 plus 85.44. This gives me 235.44 megapascal. This is my sigma 1. Done. Okay. Now what is sigma 2? Sigma 2 is equal to sigma x plus sigma y by 2. Nag is minus tau max. So no need. You can straight away put the values here. Just substitute the values. What is the value? Mu khamseen nag is 85.44. This gives me how much? 150 minus 85.44. This gives me 64.8 0.6 mega Pascal. This is my sigma 2. Okay. So you have sigma 1, you have sigma 2, theta 1, theta 2, tau max, and then you have got all the values over here. See, what is this value? You have got positive, is it not? This is positive, this is also positive. So what I will do, I will show like this. This is my positive sigma 1. Sigma 2 is also tensile. See, on these planes you have got sigma 2 and this is sigma 1. If you get a negative value, you have to show in the opposite direction. Okay, you have to show it in compressive direction. I hope you see this one very clearly, isn't it? In the second problem, we will try to manipulate this one and get see what happens if compression comes and tau xy becomes negative. We will check it.